is just contracting. There's really a very, very precise process of how we allow our muscles to contract. For instance, when you walk in your kitchen, let's say that mom has been cooking on the stove and you don't realize the stove is hot, and you touch the stove and immediately you jerk your hand back. Well, when you do that, it takes you just a split second. But what actually occurred was touch receptors in your integumentary system registered the heat. Then it told the nerves in your body, which then carried that message up your nerves into your spinal cord, up to the brain stem, into the brain, where you were immediately sent over to a memory of your mom saying, don't touch, hot, hot, hot. And then sent over to the processing portion of your brain that says, move your hand, dummy. And then move your hand, dummy, left the brain, went down the brain stem, down the spinal cord, back out to the nerves, where it then sent out a series of reactions so that your muscles can jerk back. Okay. So today we're going to talk about what happens when the message, move your hand, dummy, gets to your muscle. Okay. So we're going to start with the very first portion of the muscular contraction, and it is called the neuromuscular junction. Neuromuscular junction. This particular portion is a chemical and electrical component of our muscle contractions. So when you look at the word neuromuscular, it kind of gives you an idea that we're going to be dealing with a nerve and we're going to be dealing with a muscle. And if you think of like a junction in a road, a junction is where two roads meet. So like, you know, you're driving down the road and you come to a stop in the road. This is a junction. It's where two roads meet. Well, this is going to be where a nerve meets the muscle. So we're going to draw that. So we're going to draw a little motor axon. It's going to look something like this. And under it, we're going to draw a muscle. So this is a muscle fiber. And this weird little foot thing right here, this is a motor neuron. Okay, so let's stop right there. Does anyone have any questions about the neuromuscular junction, what it is? Is everybody good? Okay, so this is where the motor neuron meets the muscle, and that little section right there is what we call the neuromuscular junction. Okay, so you've touched the stove and your brain is going to send a message down, and it's going to say, move your hand, dummy, move your hand, dummy, move your hand, dummy. Okay, this little section right here, these little arrows, this is what we call an action potential. An action potential is just what its name is. It means it has the potential to create an action. Our brain is telling us, move your hand, dummy, move your hand, dummy, move your hand, dummy, and it has the potential to make us move our hand. Okay, so right here where this action potential comes down the motor neuron, there's going to be some stuff that takes place in this little section. This little section right here where the junction is, there's a lot of cool stuff going on, okay? One thing that you're going to find in this little section are these little bitty bags. They're called vesicles. I tell people, think of them as like little bitty Ziploc bags, okay? These little bags are vesicles, which you learned in biology, and in those vesicles is a chemical. That chemical is called acetylcholine. acetylcholine. We're going to abbreviate it ACH. Okay, so move your hand, dummy, move your hand, dummy, move your hand, dummy, move your hand, dummy, comes down the motor neuron from the brain. It's going to get to this little junction right here, and when it does, it's going to hit these vesicles, and those vesicles are going to pop open. And so ACH is allowed to escape these vesicles, okay? So ACH is going to leave the vesicles. Now this is important because ACH is like an usher. It's kind of like when you were little and you had to walk across the street. Give me a thumbs up if your mom, when you were little, used to hold your hand. Yeah, because she didn't want you to get squished by cars because then your clothes wouldn't fit. And so she would make sure that you got across the road safely. So she would hold your hand. Well, ACH is kind of like mom. But ACH is not going to hold your hand. Instead, it's going to hold an ion's hand that we consume a lot of. Now, some of you may think or have heard one of the things that you need to stay away from if you're going to be doing athletic activities or if you're having a lot of muscle cramps, one of the things that we're supposed to stay away from is salt. And that's because salt has a chemical in it known as sodium. Na is the symbol for sodium. We get this from our food. Okay, so there's going to be inside here a whole lot of sodium. And I'm going to highlight my sodium with this yellow. Now, sodium is important. We need sodium for our muscles to contract. Individuals who have dehydrated, which means that their water, but not only their water, but their electrolytes have been depleted. One of the things that happens to them is they can't have muscle contractions. Elderly people, sometimes in nursing homes who are on their own, who maybe don't have someone to remind them to eat and drink like they're supposed to, they dehydrate really, really easily. And one of the things that will happen is they will become very lethargic, meaning that they can't move around, much like some of you in the morning. All right, meaning you have no energy, you can't get up, you can't move around, and they'll have trouble just getting out of the bed. Okay, and it's because they've lost their sodium. Without sodium, you can't have a muscle contraction. Too much sodium, you'll have too many muscle contractions. So we have to keep a balance. So when the message comes down the neuron, it triggers these little vesicles to pop open. Acetylcholine leaks out, and acetylcholine sends the sodium into the muscle. So we end up with a whole bunch of sodium rushing into this muscle. So I've put a bunch of NAs going into the muscle. Okay. So let's run through this section again, okay? This is the neuromuscular junction. It's chemical and it's electrical. So we touch the stove is hot, our brain tells us to move our hand, move our hand, move our hand, move our hand, move our hand. When the message or action potential reaches the bottom of the motor neuron, it triggers these little sacs or vesicles of acetylcholine to pop open. And the acetylcholine rushes out, grabs sodium, which we get from our food and drink, and pulls it into the muscle. Okay, so is everybody good so far? Does anyone have any questions? All right, does everyone understand?
Wait, so after the message pops the vesicles, what happens?
The acetylcholine grabs the sodium and takes it into the muscle. You need acetylcholine to get the sodium into the muscle. Without acetylcholine, the sodium stays on the outside of the muscle, and we need it inside. Okay? So acetylcholine it's like a parent. It grabs the hand of the sodium and it moves it to where it needs to go.
Okay.
All right. So is everybody good? Okay. So I was telling you that the neuromuscular junction is chemical, and this is all the chemical portion, but it also has an electrical component. This sodium continues to move all into this muscle fibers. This muscle fiber is just continuing on down the line, okay? So we have all this sodium right here. Well, these electrical charges on this chemical, which is called an ion, these electrical charges on the ion are very important because this allows this action potential to continue on down the muscle. I tell people, think about, Christmas lights. If you have Christmas lights and all the light bulbs are where they're supposed to be and everything's like it's supposed to be, all the lights will light up all the way down the strand. But how many of y'all at Christmas time, give me a thumbs up, how many of y'all at Christmas time pull out your Christmas lights and one bulb has gone out and everything from that point is now gone out? Yes, they tell you that, it'll continue to burn. That's phooey. I don't believe it because we end up buying Christmas lights every single year because one or two bulbs will burn out and we can't figure out how to fix it. Well, this is kind of like how your muscle is. As long as you have these ions, the electricity can continue to move. So sodium is important because it's going to allow this action potential to continue. So what I'm going to do is I'm going to continue to draw my little arrow. That action potential moves down this membrane of the muscle, and that membrane is called the sarcolemma. So this action potential, because the sodium is there, allows the action potential to continue to move, okay? So let's just kind of put that into some good words here. So I'm going to type it over here in the chat box. Can y'all see the chat box?
Where do you write sarcolemma?
I'm fixing to type it out for you. But this little membrane, that's the sarcolemma. But I'm going to type it in the chat box for you, okay? All right, so can y'all see the chat box? All right, so the first step is our action potential leaves the brain, travels down the motor neuron, and stimulates the release of ACH from vesicles in the neuromuscular junction. Can y'all see that? So the action potential comes down. It stimulates the release of acetylcholine from the vesicles right here at this neuromuscular junction. Okay, so once the ACH has been released, it moves sodium into the muscle, and that forms what we know as an electrochemical gradient. It's an electrical gradient formed by chemicals all along the muscle membrane or the sarcolemma. Okay, so is everybody good?
Yeah.
This is step
Almost.
1. There are 3 steps. So that's step 1. We're going to go through the other 2, okay?
That's just step 1.
That's step 1.
So step 1 has 2 steps.
Yes. Step 1A and 1B. I guess it would be better. I do it both ways because some people like the picture and some people like the words. And then there's people like me who like the words and the picture, because if I can see it and read it, then I can put stuff together. Okay. All right, so are we good? Okay. Well, let's go on to the next part, okay? So on the next part, this muscle membrane is going to continue on down, okay? So I'm going to draw, oops, is that my wrong marker? That's right. All right, it's going to continue on down. And down here, you're going to find a structure that looks something like this. This weird butterfly looking structure is known as the sarcoplasmic reticulum, which may bring back nightmares of biology 1 when you learned endoplasmic reticulum. This is the exact same thing as the ER, but we call it sarcoplasmic because it's unique to muscles. And anytime we see the prefix sarco, it means muscle. Inside the sarcoplasmic reticulum, we're going to find some important chemical. Whoops. This important chemical is one that we get from dairy products known as calcium. And calcium is a Ca, and it is also an ion, which means it has an electrical charge as well. So some of our calcium gets stored in our bones, but other calcium molecules or our ions get stored in other places. And one place that it gets stored is in our muscles. Calcium is important because calcium allows our muscles to actually go through the mechanical part of contractions, okay? So this little section right here is no longer the neuromuscular junction. Now we've moved into the second part. This part is known as coupling excitation to contraction. Coupling excitation to contraction. And it is also a chemical reaction. Okay, so same action potential. Our brain is telling us to move our hand, move our hand, move our hand. And have you ever seen Looney Tunes? You know, Bugs Bunny, when he's running from Elmer Fudd, he'll run really, 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 really fast, and then he'll jump into a rabbit hole, okay? I tell people that along the sarcolemma, along this membrane of the muscle, there are these holes. And these holes go down like little tunnels into the sarcoplasmic reticulum. If you're looking at this right here, it looks like a letter of the alphabet. Looks like a what letter? If you looked at it like this, there's the top and there's the bottom. What letter is that? So like a T to you? It looks like a T to me. So this is called the T system because it looks kind of like a T. This little hallway or channel or rabbit hole, that is called the tubule. So what happens is, move your hand, move your hand, move your hand, move your hand, falls down in that little hole, that T system, right down that little tubule. And when that happens, that's very important because that signals the release of calcium. So now calcium is going to rush out of the sarcoplasmic reticulum, and that calcium is going to move in between all of our fibers, and it's going to cause them to contract. And that's part 2. Okay, so the action potential continues along the sarcolemma, goes down the T system's tubule, and triggers the release of calcium ions from the sarcoplasmic reticulum. And this is chemical. So for step 3, the action potential continues down the sarcolemma until it goes into the T system tubule, which terminates with the sarcoplasmic reticulum. That's step 3. The calcium in the sarcoplasmic reticulum is released and causes a muscle contraction. All right, so I'm gonna give everybody a second to get that down. Then I want to run through the whole thing again from start to finish, and then we'll do the last little step, okay? Everybody good so far?
No.
No.
Okay, so the first 2 steps are in like the first
Neuromuscular junction.
junction. And
Mhm.
then steps 3 and 4 are in
Coupling excitation to contraction.
Okay.
Yep. Is that your babysitter kid? Your babysitting kid?
One of them. There's 3.
Woo! Okay, so I'm going to zoom out real quick and run through the whole thing so far, okay? And y'all just follow along with your picture. Okay. So what happens is our brain sends a message in the form of an action potential down the motor neuron. When it reaches the bottom of the motor neuron, it triggers these vesicles which hold ACH to burst open. The ACH brings sodium into the muscle, and the sodium creates an electrochemical gradient along the sarcolemma of the muscle. The action potential continues down the sarcolemma until it goes into the T system tubule, which ends in the sarcoplasmic reticulum. The sarcoplasmic reticulum holds the calcium, and this triggers the calcium to be released. Now that we have the calcium, we can actually go through a muscle contraction. So all of this is leading to us being able to move our hand. Okay, this is all the pre-steps for us to move our hand. So now we got to actually do the mechanical part. Okay, so is everybody good? Thumbs up if you're okay. If you're not okay, unmute and say, I'm not okay. All right.
I'm not okay.
Who is that? What's wrong, Lisa?
Lisa,
What's wrong?
everything.
Do you understand this sort of?
Yeah, mostly.
Okay. And I'm going to look to see if I see a video that I might can link in the classroom to help y'all out too. I know this is tough, but the good thing is y'all don't have to take a normal test on this. So yay for you. Y'all lucked out. Did you start this virus? Did you begin the pandemic in China knowing that by this time when we got to this unit, it will have reached us so that you would not have to do this as your discussion question? Who is the virus mastermind within y'all? It was Lisa. I knew it. I knew it.
No, it's Cameron.
Cameron definitely.
I forgot this was gonna be a discussion question, and I wasn't sweating, but now I am. Is this gonna be available?
What?
Are we gonna be able to rewatch
Yes.
hold on.
I'm recording this right now and I'm going to upload it to YouTube and then I'll link it in the Google Classroom.
Okay, because I was having a crisis because I forgot this was a discussion question that I had to actually remember and think about.
Yeah, well, okay. Well, now you're good. All right, so let's look at the last thing. What?
How are you going to do the discussion question? You're just, like, when you put us on Zoom, you're just going to ask us?
I'm going to ask you questions. I'm just going to ask you questions. You're actually, right now, your first order of business is you've got to take a quiz on this. So the quiz is on the Google Classroom. So once you've learned this and you feel confident answering questions about it, then you're going to go and take the quiz.
Wait, so the quiz is not the discussion question?
The quiz is on the discussion question. It's not your discussion question. When we do your assessment, you're going to answer questions about this.
Okay.
All right, you can do it. All right, here we go. Let's go through the last little part. Okay, so the last thing that's going to take place in this whole contraction is the mechanical part. So I'm going to pretend like we're zooming into the muscle. I tell people, think of like Miss Frizzle on the Magic School Bus. You know how they get in the Magic School Bus and they would go into something? Well, today we're going to go into the muscle, okay? So if we were to zoom in on an actual muscle fiber, we would find that a muscle fiber has two parts. One part is a thin filament that just looks like a string. And that thin filament is made of a protein known as actin. There is a second part of our muscles. If you zoomed way in real deep into the muscle fibers, you would find this thick filament that looks kind of like a balloon. And the thick filament is made of a protein known as myosin. When you eat a steak has lots of protein. The protein that you're eating is actin and myosin. So this is the proteins, the two of the major proteins that make up our muscles, okay? So if you think back to biology, the best example that I can give you is when you were learning in biology about enzymes, your teachers kept talking about lock and key, lock and key, lock and key. Well, thin and thick filaments kind of follow the same premise as a lock and a key. On thin filaments, there are these little spots known as an active site. And when the active site is exposed, the thick filament joins to it. The thing is, though, most of the time, if we're not contracting, your active site is covered up. And if it's covered up, the thick filament can't connect, which means you can't have a muscle contraction. The secret to exposing the active site is calcium. So when all of this happens up here and the calcium comes out, high calcium levels expose the active site and allow your muscle fibers to connect. We call this connection a cross bridge. A cross bridge. So this portion of the muscle contraction, it has a name too. It is known as the sliding filament. This is the mechanical part of a muscle contraction. Okay, so I'm going to show you how this works. Let me pull up my my PowerPoint. So I always talk about, whenever we're discussing the sliding filament, tug of war. When my kids were younger, Jackson, he was in Cub Scouts. And one of the things that we used to do in Cub Scouts is we would go to these big Cub Scout campouts. And the kids, each individual Cub Scout group would participate in games. And one of the games that we always had was tug of war. And my little group of Boy Scouts dominated on tug of war. What they would do is I would have my bigger scouts, which was usually Artrell and Jackson. They would get at the end of the rope, and Artrell would take that rope and wrap it around his waist. Jackson would get in front of Trail, and then I had a little boy named Brantley and a little boy named Blaine that got in front of them because they were pretty stout. And then we had a kid named Jesse who was pretty stout. He got in front of Blaine. And then we had a couple little boys who were little squirts. They were just there participating because they really weren't doing anything. But my boys learned that the way to win at tug of war is to not move your feet. Okay. So imagine that you're pulling on a tug of war rope and you want to pull that other team over to you. You plant your feet and then you move your hands up the rope and pull simultaneously. That's how the sliding filament model works. The sliding filament model works by the little myosin head binds to the active site right here on this particular thin filament. Then what it does is it goes through and pulls that filament backwards. Then it lets go and it grabs the next active site and pulls it that way. And that allows your muscles to get tighter and tighter and tighter and tighter. How many of y'all have ever had a muscle cramp in the middle of the night? It's not pleasant, is it? You wake up, you pointed your toes, and now your whole leg has gone into crisis. You can't get out of the bed. You're just laying there screaming bloody murder because you can't move. Well, what's happened is your cross bridges have built, and these thick filaments are pulling your thin filaments very, very, very tight into a knot, and it won't release. Okay, that's the mechanical portion of a muscle contraction. Every time you breathe, every time you move your pencil, every time you click, yes, I'm still watching on Netflix, every time you do anything that requires movement, you are going through this sliding filament model. And it has to have all this other stuff in order for this to work. Okay? So let's zoom back out, go through the whole thing. But first, I want to type in the box what you need to know for the last little portion. Okay, so let's go over here to the box, and I'm going to put number 5. Once the calcium has been released, it triggers the active site to be exposed on the thin filament of actin. The myosin head connects to the active site, builds a cross bridge, and begins to pull like in tug of war. Okay, and that's the mechanical portion of a muscle contraction. Okay, so let's go through the whole thing again. And then I'm going to tell you the last little part, which we don't draw, about how we relax, okay? So here we go. Brain sends the message in the form of an action potential to move our hand. When the action potential reaches the bottom of the motor neuron, it triggers the release of acetylcholine from vesicles, which then draws sodium into the muscle. The sodium creates an electrochemical gradient so that the action potential can continue down the sarcolemma, down into the T-system tubule to release calcium from the sarcoplasmic reticulum. The calcium allows the active site to be exposed so that the myosin can connect and build a cross bridge. And then the myosin begins to pull the thin filament like tug of war, okay? So the last thing that I want to talk about, we're not going to write it on the picture, but it's relaxation. Once you've pulled your hand up off of the stove, you don't want to stand there like a weirdo for the next 5 hours holding your hand in a contracted state. So a couple things happen for our muscles to relax. So the first thing is calcium is pumped back into the sarcoplasmic reticulum. I'm typing it out for y'all, so just give me a second. Which covers the active site and breaks the cross bridge. All right. Acetylcholine esterase is an enzyme that breaks down ACH, so no more sodium can enter, and sodium is pumped out of the muscle by potassium with the sodium potassium pump. Okay, so once it's time to relax, calcium needs to go back into the sarcoplasmic reticulum. So calcium is pumped back in with an enzyme known as calcium ATPase. That moves the calcium back into the sarcoplasmic reticulum. So now this can break and relax. We need to get rid of the ACH to keep more sodium coming in. So acetylcholine esterase breaks down the ACH, and that keeps more sodium from coming in. And then to get the sodium out, the sodium potassium pump, which you talk about in biology, pumps potassium in and pushes the sodium out. And then that allows your whole muscle to relax. And that is your discussion question. So it seems like a lot, and it is, but it's, if you keep it in little chunks, then it makes it a little easier. Okay, if you notice, it covered like 20 something slides in your PowerPoint. Okay, so in your PowerPoint, I've broken this down into little bitty pieces, so that way you can kind of follow it along as you read the PowerPoint and read it and look at the picture at the same time. I also included the book's picture, which is a little bit clearer than mine, but they just kind of draw it a little differently, but you can look at that picture as well. So what I'm going to suggest that you do is, while you're already kind of on the mindset of school, take about 30 minutes, read through your PowerPoint again, follow along with your picture and then the notes that you wrote down from the chat box. And then if you feel comfortable, go take the quiz in the Google Classroom, okay? So does anyone have any questions so far?
So if we just study what like we just went over, will that be like?
That's what you need to know. This is going to be the same thing that you're going to read in your notes. This is the meat of that PowerPoint. Now, I will tell you, how quickly does it take you to move your hand off of the stove when you touch a hot stove?
2 seconds.
Really fast.
Like a split second, not even a full second. It took us 45 minutes to write down what happens, okay? So you can see this is an extremely complicated process, but it takes place just like this. Do you know how old people, a lot of times old people will burn themselves on their stoves? They have found that as you age, this process moves slower and slower and slower. That's why Granny's reaction time is not as good as your reaction time. You throw a ball at Granny's face, it's probably going to hit her in the face, okay? That's why when Granny drives and an 18-wheeler's coming at her, it takes her a few minutes to realize an 18-wheeler's coming at her, whereas we immediately know what's happening, okay? And that's because all of this is based on your neurological, and we know that as people age, a lot of times this begins to break down, which slows this down. But for us, it happens almost simultaneously. From the time we touch the stove to here, it's a matter of just a split second. Okay, so does anyone have any questions?
No.
I guess
Okay.
not.
Well, I'm going to try to get this on YouTube ASAP. And as soon as I have it on YouTube, I will put it in the Google Classroom so you can go back and watch it and kind of go through what I said. And then I would watch that, read through my notes, and then I would try to take that quiz today. Yes, Addie?
Okay, so I didn't mean to like interrupt, but
That's fine.
there's 4 steps in total, and then there's like sub steps in the.
Yeah. this is step 1, and it
Okay.
had 1 and 2. This was step 2, and it had 3 and 4.
Uh-huh.
This is step 3, and it had just step 5 in it, or the 5th little thing. And then the whole thing, to relax the whole thing, that's at number 6.
Okay, okay, just making sure.
Yeah. Okay, so is everybody good?
Yeah.
All right, well, y'all did very well. I'm going to end the meeting, and if you have any questions before you take the quiz, feel free to email me or shoot me a remind, and I'll get back with you as soon as I can, okay?
Yes, ma'am.
All right, good to see y'all. Bye-bye.
Bye.
Bye.